This video is intended to demonstrate the process of connecting a PL259 connector onto a 50-ohm coaxial cable. Installing a connector can be done two ways. The first method is to prepare the cable and then use a crimping tool to fasten the connector to the cable. This is by far the quickest method, but not the most reliable. The most reliable method is to solder the connector onto the cable. As I get started in presenting this program to you, I want to emphasize that I hope no one is intimidated by the information that's presented in this video. The thought of soldering equipment might be a very foreign and scary concept if you've never had any experience with soldering. I don't want people to be turned off by those thoughts or feelings. Soldering is an easy process that anyone can learn, and it's a process that if you practice, you get better at it. In this video, I'm going to show you a couple of welds, one that's really clean and one that's really gnarly. I will also need to introduce you to the tools. So let's get started by reviewing the tools first. I will be moving from left to right as I quickly describe the tools used. The first tool is a box cutter. The cutter is preferred because it has a changeable blade. The blade needs to be very sharp to cut through the jacket without having to press so hard that the insulation wires get damaged. Next is a scissor. The scissor is for giving the wire a haircut. The small, tiny screwdriver is for separating the wire braid. The tube contains rosin core solder. At the top of the picture is the soldering pen, and at the bottom of the picture is the wire cutter. Next to the tube of solder is rosin paste flux. Make sure it is rated for electronics. It aids the solder in flowing easily. And the last thing that we're looking at is the two connectors that will be mounted on the cable. This is an image of a soldering pen, often referred to as a soldering iron. It heats up quickly, has a temperature control to maintain consistent heat, and a very long cord connecting the pen to the controller. This is helpful when you need room to work. This is 1/2-inch shrink tube. It is mounted on the connector as the final application. If connectors are frequently being taken on and off equipment, the stress on the cable and connector may lead to a failure. Shrink tube provides stability and stress relief for the connector mounted on the cable. When heat is applied, the tube begins to shrink, and the adhesive glue inside the tube bonds to the connector and cable. In my opinion, automotive shrink tube works best for this job. To apply the shrink tube to the cable and connector, use any source of heat. You can use a heat gun, a butane torch, and even a hairdryer. The heat gun is the best option for this process. Whatever method is used, the heat source needs to produce enough heat to shrink the tube, but not enough heat to burn the tube. This is a 20-foot coaxial cable which will be used for this demonstration. The cable is bound with a zip tie and has about 10 to 12 inches free on each end. By doing this, the operator has enough working room to be able to mount the connector without having the cable getting in the way. This is a PL259 connector assembly. Looks kinda lonely sitting there all by itself. This is the connector broken down into its three parts. The connector body is in the middle of the picture. On the left is the retaining ring. Notice that there are checkered diamonds on the retaining ring. This will help remind the operator which end is up. The retaining ring is applied from the bottom and screws onto the connector in the finishing stages. On the right, we have the reducer. The reducer allows for the use of a smaller cable on this connector. For this application, 50-ohm RG8X cable will be used. This cable is nicknamed Mini 8. The reducer screws into the bottom of the connector. Looking at the connector body, the plug is the part of the connector that is inserted into the SO239 connector on the radio. The barrel is the connection point for the cable. There are two locations where solder is applied. The barrel has 4 ports for solder, so including the plug, there are only 5 solder points. This is not a big job. Now it's time to move on to the actual process. Now that I've gotten you familiar with all the parts and the tools, it's time to move on and start getting ready for the actual solder. The operator loads up the cable with 3 things: the shrink tube, retainer ring, and the last item is the reducer. Look at the direction of each one of the items on the coax cable. Look at the direction of the diamond pattern in relation to the end of the cable. Now focus on where the lobe of the reducer is located. The operator will confirm placement and move the items down to create space to work with the body of the connector. We teach our students to measure their connectors without a ruler. What happens during a crisis if you need to replace a connector and can't find a ruler? Ask the zombies for one? In this step, the outer jacket will be cut off to reveal the braided shield, the braided copper wire. This will be the focus of the next few steps. The cross-hatching of the wire braid is impressive. The focus of this step is to debraid the wire shield. First, the wires are pulled down and out, away from the cable. Once the wires are loose enough to insert the tiny screwdriver between the strands of wires, the screwdriver is used to separate the individual sections of the braid. The idea is to free the individual wires, all the way down to where the jacket has been cut off. The wires need to be pulled out straight, so they may be pushed down and formed around the reducer. We call this look hair on fire. This step demonstrates the removal of the white plastic insulator surrounding the center conductor wire. Cutting off the white insulator is a little more difficult to do. The white plastic is very durable. This step requires more care so as not to damage the center conductor wire. The goal is to keep the center conductor wire as straight as possible when the plastic insulator is removed. If the wire starts to unwind, it can be rewound with a simple twist of the wire. Looking at the center conductor wire, the insulator, and the upbraided shield wire, notice that no wire crosses the insulator. If wires cross this boundary and connect with each other, the connector will be shorted out and non-functional. In this step, the reducer is slid up the cable and tucked under the debraided wires from the shield. It is important to make sure the connector is pushed up as close to the cut in the jacket as possible, because the wires will extend over the threads of the reducer, preventing it from being screwed into the connector body. This is where the scissor is used to give the wire a haircut. The wire is cut all the way around the reducer, just above the threads of the reducer. Once the wires are cut down, the reducer can be smoothly screwed into the base of the connector. Before inserting the reducer into the connector body, flux paste is applied to two areas of the wires. First, put a dab on the end of the conductor wire. Then spread some flux paste on the wires where we gave it a haircut. By applying a light coat of flux paste across the wires, the flux will aid solder flow when applying solder to the 4 holes on the connector body. Now looking down the barrel of the connector body, the hole for the plug is visible. This is where the conductor wire is going to reside and is the reason for keeping the conductor wire straight. Now the reducer will screw in smoothly to the body of the connector, and the conductor wire will slide into the plug nicely. The reducer should be screwed in tightly. Looking down the plug, the conductor wire is visible. This is a good sign. The conductor is now ready to be soldered. The first area to solder is the plug. By soldering the plug first, the conductor wire is going to be frozen in place. This aids in keeping the connector together while working on the rest of the connector solder points. Now looking at the side of the connector, you're going to see the wires visible through the port window. These are our solder points. You may or may not see wires in each of the ports. Sometimes you may only see wires in 2 or 3 ports. Don't get excited. This is normal and expected. Whether wires are visible in the window or not, all ports will have solder applied. This fully bonds the reducer to the connector body. This is an easy step. In this step, the only task is to screw on the retaining ring to the connector body. The retaining ring is used to secure and hold the connector to the piece of equipment it is being plugged into. The focus is now on the last element to be applied. Move the shrink tube into place and make sure it is set in the appropriate position. Push the tube up on the connector and adjust the position in relation to the retaining ring, making sure the retaining ring can move down far enough. The retaining ring cannot inhibit the plug from being inserted into a corresponding connector. Also, the tube must be far enough up on the connector in order to properly adhere to it. When heat is applied to the shrink tube, it begins to form itself around the cable and the connector. Too much heat can burn the shrink tube. Not enough heat, and the adhesive and tube will not react and bond to the connector. This is going to be the final step in the application of a connector to a coaxial cable. In placing the connector on the other end of the cable, follow the same process. The final task is to label the cable.